Welcome to this video tutorial on xlminer, the data mining add-in for Microsoft Excel. In this tutorial, we will learn how to use the prediction tool. Prediction is the process of finding how the value of predictor variables predict the response variable based on the predictor variables, or to study the relationship between the response variable and the predictor variables. xlminer provides different tools to perform this task, which use different algorithms such as multiple linear regression, k-nearest neighbors, regression tree, and neural network. Let us look at each of these algorithms one by one, starting with multiple linear regression. In this procedure, performs a linear regression on the selected dataset. This fits a linear model of the form y equal to b0 plus b1 x1 plus b2 x2 so on until bk xk plus e, where y is the dependent variable or response and x1 x2 dot so on xk are the independent variables or predictors, and e is the random error. B0, B1, B2, so on until Bk are known as the regression coefficients which have been estimated from the data. As we have previously seen, these coefficients are estimated from the training data set. The multiple regression algorithm in xlminer chooses regression coefficients so as to minimize the difference between predicted variables and actual values. Linear regression is performed either to predict the response variable based on the predictor variables or to study the relationship between the response variable and the predictor variables. For example, using linear regression, the crime rate of a state can be explained as a function of other demographic factors like population, education, male to female ratio, etc. Let us see how to use the multiple regression algorithm for creating a prediction model from xlminer. Let us first select a data set in order to be used in the prediction. We click on Open and then select the Boston housing example in order to create the prediction set. Once the dataset has been chosen, we click on Prediction and then select Multiple Linear Regression. Since this is a demo version, only 200 rows are allowed to be selected. We click on OK, you see that only 200 rows out of the entire dataset are selected. Now, let us see the different options available in this wizard. This area contains all the variables available in the dataset. So we may use either of them to be present in as the input variables. We will select all variables except the last two as input variables and then select this as an output variable. Once these selections have been made, we click on Next to proceed to the next step. Here you can see that step 2 of 2 is visible as a wizard. Here there are various options in which you have residuals as standardized and unstandardized. Unstandardized, when selected, is the unstandardized residuals are displayed in the output. Unstandardized residuals are computed by the formula unstandardized residual is equal to actual response minus predicted response. If the standardized is checked box is checked, the standardized residuals are displayed in the output. Standardized residuals are obtained by dividing the unstandardized residuals by the respective standard deviations. Let us select the standardized results and then a detailed report and lift charts to also be selected. After choosing these options, click on the models you wish to view in the output. We select all these values and then click Finish. The wizard is creating the prediction model and then it is copied in a new workbook. Once the output is visible, you can see that there is an output navigator which contains the links to the various outputs available, and then here is a summary of the input. We can see that the number of rows selected are 200 and this is a list of the input variables which are 13 in number. The output variable and the constant term are selected or no. These are the parameter options selected by us to be shown in the output or not. We can see here the prediction of training data report shows us the predicted value, the actual value, and the residual, that is the difference between the predicted value and the actual value. So using this, viewing this table, we can see the residual or the error in the prediction and the actual value. We can view this for fitted values by clicking on it. You can see how the fitted values, the residuals, and the standard residuals are visible in this. You can also view the lift charts. A lift chart are visual aids for measuring model performance. They consist of a lift curve and a baseline. The greater the area between the lift curve and the baseline, the better the model. So you can see that a lift chart is created based on the training data set, and you can see that this is the cumulative MEDV when sorted using predicted values, and this is the cumulative variable when using average. We can also view the lift chart for the validation set. You can view the summary report, which shows the total sum of the square errors, the root mean square error, and the average error that occurred during the creation of the prediction model. This also shows us the overall time in seconds required to create the model. You can see this is how we create a multiple linear regression model using xlminer. Let us now look at using the k-nearest neighbors algorithm to create a prediction model. The k-nearest neighbor technique is like a regression technique. Here, the nearest neighbors to a particular object have more weight than the distant ones. An object is classified according to a vote by its neighbors. It is then classified to the class most common in its k neighbors. Let us see how to use this tool to create a prediction model. Here, let us use the Boston Housing Excel sheet as our data source. Once the data source is selected, click on prediction and then k nearest neighbors. As previously, only 200 rows shall be selected as we are using the demo version. You can see that a wizard is open containing the variables in the dataset and an option to select which variables do we want to be used as the input variable in creating the prediction model. Let us select the above variables excluding the last two, and then select this in the output variable. Once these have been done, let us now look at how to use the multiple linear regression algorithm to create a prediction model. First, in order to use this data, in order to be used for prediction, we need to create a validation set as well as a training set. We need to create a partition of 60:40 ratio of training and validation set. Since we have a limit of 200 rows for our training set, here the wizard automatically select is as 40 and 60%. We create a partition. After selecting the variables, click on OK. The partition is being created. Once the partition is created, we can select the prediction tool, under which we select the multiple linear regression option. Since it's a demo edition, we can select only the first 200 rows. Click on OK and then select the input variables and then MEDV as the output variable. Click on next. Here you can see there are options that need to be selected in order to view in the output. We click on these options that we require to be seen in the output, and then we click on the best subset. We will click on the best subset if we have a large number of predictor variables. After selecting the output options, we click on finish to create the prediction model. Once the output is open, we can see an output navigator which contains the links to navigate to the particular outputs. Here we can see a summary of all the input data we have provided, as in the number of records, the input variables, the output variable, and the option selected to be viewed as the output. Here we can see the regression model, which contains the regression coefficients for each of these variables as well as a standard error that occurred during the creation of the predicted values. Let us view at the regular regression model and then add a detailed report of the prediction of training data. You can see that there is a column containing the predicted value, the actual value and the residual value. The residual value is the difference between the predicted value and the actual value, and we have this for all the rows contained in the entire data set. We go back to the navigator in order to see the lift charts. A lift chart is a visual aid for measuring model performance. It consists of a lift curve and a baseline. The greater area between the lift curve and the baseline, the better the model. You can see that this is the predicted value line and this is the line created using average values. Here you can see the table containing the decile wise lift chart training dataset, which is drawn from this data, which contains the mean, the standard deviation, the minimum and maximum values. Based on these values, this histogram is drawn. We can also view a summary of the entire output, which shows the total sum of the squared errors, that is, the error between the prediction values and the actual values, the sum of all those errors. This shows the RMS error or the root mean square error and the average error. The average error is usually small because the positive errors nullify the negative errors. We can also view the time required to create the entire prediction model. This is how we create a multiple linear regression prediction model using xlminer. Let us now look at creating a regression model or a prediction model using the k-nearest neighbor method in the next videos. For more presentations on video tutorials on data mining, please visit dataminingtools.net. Thank you.